Good day, all. My name is Darren Giuseppe, and this is the Key Concept series. The Key Concept series is basically a series of videos that I will be doing where I am looking at Cape Pure Maths Unit 2. I'm going to just be looking at the key concepts or the key things that I believe that students need to make sure that they know for their exam. Um, so that would mean we're going to look at Module 1, Module 2, Module 3. The first thing we'll be looking at in Module 1 is, or in this video, we're going to look at the first topic in Module 1, which is complex numbers. And what we're going to do is just a quick intro into complex numbers. So without further ado, let's get straight into it. So the topic, big heading, is complex numbers. And the question is, what is a complex number? And simply put, a complex number, you think complex and you're thinking it's difficult, but that's not the case. A complex number is just a number that is denoted by z is equal to a plus bi, where the a is called the real part of the complex number. So we denote it by REZ. And the B is called the imaginary part, IMZ, of the complex number. The reason why B is called the imaginary part because it is connected to the imaginary number I. And we'll get into what I is a little later down in the video. So we say that a complex number is a number denoted by Z is equal to A plus BI. A is your real part and B is your imaginary part. Another point to note, so that's the first point on complex numbers that I want to note. The next thing about complex numbers we notice is that the system of complex numbers is an expansion or an extension on the set of real numbers. So prior to this, when you did unit 1, you would have just known, or you would have just looked at the number system, would have stopped up to the real set of numbers or the set of real numbers. But now in unit 2, we're looking at, or we expand on it, and we're getting into the realm of the set of complex numbers. So this is another big point. The set of complex numbers is an extension of the set of real numbers. It's an extension, and it's denoted by the C here, right? So that is very important to just take note of. And if you were to just look at it from a Venn diagram perspective, this would be, let me just change the color. This would be, let's say, the set of real numbers here, and the set of complex numbers would be the C here. So you're seeing that the set of real numbers, it's within, it's a subset, in other words, of the set of complex numbers. So that's key. That's basically what we're saying. So you're seeing that extension. It's an extension. The set of complex numbers is an extension to or of the set of real numbers. So that's an next point to note about the about complex numbers and the system of complex numbers. Last point, but certainly not the least point, in terms of complex numbers, what we need to note is that prior to unit 2, right, you all would have solved quadratic equations, right? And in any instance where you got a quadratic, and when you solved it and you got x is equal to, let's say, the square root of a negative number, let's say the square root of -2, you would have said no solution. You would have said no solution. What complex numbers does is, let me just bring this down a little bit. You'd have got something like this. Yeah, x is equal to the square root of a negative number. But from the time you saw that, you would say no solution immediately. But what complex numbers does is it allows us to now find a solution or have a solution to questions where previously we had no solutions. So that is the next point. And how it does it is by using, or by the introduction of this I here, which is the imaginary number. And we will look at what it is. So knowledge of complex numbers allows us to solve quadratic equations that previously had no solution, and that's key, right? Whenever we got x is equal to a negative square root, that was, we would state that it had no solution. But now, because of the introduction, or because of knowledge of complex numbers, we could actually find solutions for these quadratic equations, or equations where you have the, right, the solution is the square root of a negative number. And we can find the solution of this because of the introduction. This is done by the introduction of the imaginary number. And that's this guy, I is equal to the square root of negative 1. So these are just a few introductory points on complex numbers, things that you should know, basic stuff, but make sure that you understand it for the exams. So let's just run through it really quickly. Again, the first point is that the complex number is denoted by z is equal to e plus bi. And so in some books they use z is equal to x plus iy, or that, it doesn't matter. Remember, these are just arbitrary terms used in, or arbitrary letters used in the place of numbers. And you know that this is your real part, this is the imaginary part, A and B respectively. And then we see also the next point is that the complex number, or the set of complex numbers, is an extension of the set of real numbers. So it's an extension. And lastly, we have knowledge of complex numbers allows us to solve quadratic equations, or equations in general that would have had, or that would previously had no solution. So, and this is done by the introduction of the imaginary number I is equal to the square root of negative 1. So that's basically it on this introductory video on complex numbers. Guys, in the next video, we'll look at the only different topics that we need to look at for complex numbers. And guys, feel free to subscribe, like the video, share the video to somebody that you feel it will be helpful to, and see you in the next video.